Well, in pre-engineering, the goal of the program is to provide kids with the skills that I wish I had when I took engineering in university. So starting at the grade 10 level, we look at building technical drawings or engineering drawings. And in learning that, the students also learn how to use AutoCAD, which is a very, very popular computer-aided design drawing tool that is used heavily in the industry. Afterwards, we look at electronic circuits. So we start off by prototyping circuits on breadboards, so kids learn how to prototype. And then from there, once they've learned how to build a proper circuit, we then build circuits and develop soldering techniques on a PCB or a printed circuit board. And then finally, we look at computer engineering and robotics by building Lego Mindstorms robots and then programming them to do lots of different things using motors and sensors. So in computer science, in grade 10, we start off by learning a bit of web development. So how to build websites. We're not talking about building a site from googlesites.com, but actually building a site through HTML and CSS. From there, we learn JavaScript, so that third piece of building a website. And with these tools, we build awesome sites that do wicked stuff. And by the end of the year, we learn how to, you'll have the tools that you need to make a really wicked project. Some people choose to make a video game. I think at its essence, both computer science and pre-engineering develop a student's problem-solving skills. Whether it's debugging some paragraph of code that doesn't work, or by trying to decide why your circuit board isn't lighting up. By going through line by line, step by step, and trying to solve your own problems, you learn how to not make those same mistakes in the future, and that can apply to any other aspect in your life. At LaZerte, we have we have a really nice space. Our computer science, digital arts, and pre-engineering classroom lab area is just enormous. And it needs to be, because when we're doing robotics, we need a space to host our robotics challenges. When we're soldering circuit boards together, we need the space to be able to solder properly. It allows for effective group work. I've built the courses in such a way that your learning is assessed based on things that you do in class. They're based on projects. So if you're someone who doesn't necessarily like taking tests all that much and you prefer to build something and be assessed on what you've made, what you've built, this might be the course for you. So one of the best memories I have of something that's come out of this course was at an event called Science Olympics, which is hosted by the Engineering Association of Alberta, APEGA, and all of the schools in Edmonton and Alberta get together and do science challenges. And they always have a prepared challenge where they give the students a list of criteria, and they prepare for months in advance, and then when they get to the competition, they challenge each other and compete with other schools to see who is successful or the most successful. And last year at Science Olympics, I guess the year before with COVID, there was a line following robotics challenge. So the robot had to not only follow a dark black line around a track, but they also had to not run into robot cars that were in front of them. And so the kids had to figure out a way of doing that. And so what's really good about my course is that all of that learning of how to build a robot to do something like that, you're not going to get in a science class. You're not going to get in your core subjects. The only real place you get that learning is from a pre-engineering class to learn how to build a robot. The only place that you're going to learn how to code that robot properly would be in computer science class. LaZerte is the first school that I've taught at, and I haven't even thought of going to other schools.